So the next problem. A concentrated nitric acid solution contains 35% weight per volume of nitric acid, HNO3. Describe how you should prepare, so we're going to actually calculate then, describe how we prepare 300 milliliters of 4.5% weight per volume nitric acid solution. Now, hopefully you recognized that this is a dilution problem because we have a concentrated solution of which we're going to prepare a more dilute solution. So we have a dilution problem. Whenever you have a dilution problem, you should remember that you're going to use C1V1 equals C2V2. Now, part of the approach to doing these type problems, you have to link which one's C1 and which one's V1, which one's C2 and V2. A concentrated nitric acid solution. So I'm going to call this one here C1. And describe how you should prepare 300 milliliters, V2, of a 4.5 weight per volume nitric acid solution. So the 4.5 is C2. So what I need to calculate is, what I don't know, is how much of that 35% weight per volume nitric acid I need. Now the beauty of this is I don't have to convert to liters, I don't have to convert to molarity, as long as the units on this side equal to units on this side. So if I use milliliters here, milliliters are there. If I use percent composition here, percent composition there. Molarity here, molarity there. They just have to be the same on both sides. So C1, 35%. How much of that volume do I need, of the 35 do I need, to prepare 4.5% of solution, of the 300 milliliter solution? Rearranging this, volume 1 is going to equal 4.5 times 300 divided by 35, and this turns out to be 38.6 milliliters. To be more specific, it's 38.6 milliliters of 35% weight per volume nitric acid. So that's how much of the concentrated I need. Now to do the describe part. Imagine that you're going to take a volumetric flask, and then we have a special volumetric flask that has a volume that's good for 300 milliliters of volume. I'm going to put this into here. Now, this isn't quite as simple as most because this is an acid. And if you throw acid into water, always add acid. I don't know if you've ever heard that. Always add acid. You always want to add acid to a water solution. If you throw water into an acid solution, it could jump up. It could explode up and out of the flask. So to take into that account, I'm going to put about 200 milliliters of water into the flask. Then I'm going to take this 38.6 milliliters of nitric acid I need, and I'm going to put that into the flask. And then what I'm going to do after that's poured into there, I'm going to bring it up to a final volume with the bottom of the meniscus at the line, to a final volume of 300 milliliters. The point is that my final volume is 300 milliliters. I wouldn't take 200 milliliters or 300 milliliters of water and then add that to it. I want my final volume, water and acid, to equal 300 milliliters. So that's the end of this problem.